All right, let's get started. Hi, everyone, and welcome to our webinar today. This webinar is presented to you by Circonis. I'll be talking to you today about ways through which you can modernize and scale Graphite to handle the monitoring challenges of the modern enterprise. I'm Kevin Camel. I own product and customer success here at Circonis. At Circonis, we focus on delivering powerful full-stack monitoring solutions for the enterprise. Sometimes that involves Graphite, which is the topic of today's talk. I'm going to jump right in with an overview of Graphite, what it is, and the types of organizations that tend to use it. History of Graphite. Graphite was originally designed and written at Orbitz by Chris Davis in 2016, 16 years ago. At that time, monitoring and observability was still in its infancy. The tools were available at the time were like Nagios, RRD tool, Ganglia, other similar tools, and they were pretty good at their job. Are the systems up? Are they working okay? Great. And if the systems are down or not working so well, alert me, send me an email, whatever. Pretty sophisticated for the time, but Graphite took that initial concept to the next level. With Graphite, Orbitz had a foundational monitoring system that could provide insight into their network, systems, applications, and one could, for the very first time, really understand the performance of the infrastructure for Orbitz and how it was affecting their users and how it was affecting the user experience. And Orbitz later releases Graphite under the Apache license in 2008, and we see a whole bunch of companies adopt it. Many of them still using it today. Companies like Etsy, Simple, Booking, GitHub, Salesforce, Lyft. I think Reddit uses it, a bunch of others, and they're still using it. So one of the reasons Graphite became so popular was really due to its modular architecture, which allowed Graphite operators to scale certain components to handle their respective use cases. The carbon stack shown here in this architecture diagram here in the center right handles the ingestion and processing of the submitted telemetry. The Whisper database shown at the center bottom is a simple time series data store for storing the collected telemetry. And Graphite Web in the center left basically provides the visualization capabilities through which to process and analyze all of the collected telemetry. And the trick here was basically that through the scaling and tuning, it became possible for enterprises of that era to monitor pretty much everything that they had, all with a single deployment, which was pretty novel for the time. Caveat being that IT environments have significantly evolved since that time. Graphite was well suited to enterprise monitoring in the aughts, but started to run into challenges with the large scale infrastructure we find within the modern enterprise today. Gone are the days of sort of operating an IT organization with a single rack. Nobody does that anymore. These days, we are seeing explosive growth within the number of systems that power today's most popular services and software. And with this explosive growth of systems comes explosive growth of telemetry. And this is especially true for the recent trend with Kubernetes and containers, and also with serverless, which produces more telemetry than legacy systems ever could. Unfortunately, Whisper, the time series storage layer of Graphite, really struggles to keep up with today's scale. Teams often end up making compromises in order to do so, to sort of keep their existing deployments functioning. And for example, they'll compromise on the amount of data that they're retaining, or possibly they'll collect less telemetry than they would have otherwise, or maybe they deal with unreasonable query latency at times, or even sacrificing data safety, not having any redundancy for the data that's being stored. So let's get into some of the specific challenges operators face when trying to run Graphite at scale. So shown here, inability to scale Whisper. This is definitely one of the more challenging aspects of operating Whisper. Whisper is basically a flat file database where each unique series is represented by a fixed size file. And the size of that file is more or less determined by the resolution and retention configured within Whisper's config. So the model tends to work pretty well, this sort of like file-based format, when storing the data, because basically you're appending the data to the end of the file, you have a writer, and it's basically just appending data points to the end. And that works better than you might think it would. But querying or reading that data, whole other story. When responding to a query, the way that this sort of works internally is that we're going to need to go find all of the files that match that particular query. We're going to need to open each one of those files, parse that particular file, iterate to the requested time period within that file, and then basically copy the data out. And then we need to do that for every single one of the matching series. And with Graphite, it's possible you can match hundreds, thousands, tens of thousands, hundreds of thousands of series, and every single one of those files will need to be opened, parsed, iterated, find the section, pull the data out, which is super, super expensive from a disk perspective. And addressing that limitation, it often involves re-architecting in a way such to provide more and more IOPS to account for the respective read and write operations that you're dealing with. And so these activities, sort of this re-architecting, not uncommon for them to result in the loss of historic data, generate gappy metrics, maybe potentially downtime. And worse yet, that sort of re-architecting is a never-ending process because organizations, they tend to see their infrastructure footprint incrementally growing as time goes on. So you're just sort of going through that process over and over. Yep, so that's sort of the scaling challenge. I would say data safety, that's another frequently encountered challenge when running Graphite. When we talk about data safety, what I mean by that is guarantees around protecting your data from accidental loss and manipulation. So what you really want is redundant storage. That's the primary way through which to ensure data safety, that you're not going to lose the data or it's not going to become corrupt or something like this. And Graphite does support some rudimentary architectures through which you can redundantly store your data. Like, for example, you can keep two identical copies of the data within two separate Whisper backends. And this solution is sort of like a RAID 0 or striping kind of a thing. And it allows the operator to have two separate copies of the data. And on the surface, that might seem like an appropriate solution for redundant storage of the time series data. But unfortunately, there's no concept of state between replica backends like that. In the event of a software or infrastructure or network issue or something like that, the backends, they can potentially get out of sync. And once that occurs, there's not really a method through which to resync them again, other than to blow one away and then repopulate it. And of course, in a case where you sort of have these two different backends that are out of sync and you're using them to read from, which is what most people would do with it, you basically run the risk of receiving different query responses to the same query, depending on which particular backend is responding. And additionally, sort of due to the nature of Graphite, you typically cannot take down Graphite infrastructure for maintenance without losing data. So if you take down, say, Whisper, the data is just constantly streaming in. At a certain point in time, it's just going to backlog to the point where it's going to start dropping metrics on the floor, and at that point, you've lost data. Yeah, at times, some of these sort of data safety issues, they can result in some really funny things. For example, I recently came across a Graphite deployment that was still running CentOS 5 in 2022. And had been for something like 6, 7, maybe 8 years without any software updates. And while on the surface that might sound like a super great stability story, it kind of highlights from an operator perspective just how troublesome maintaining a stock Graphite deployment can be once it's stood up. The general consensus is that once it's operating, if it's working, you just leave it alone. You don't touch it. And that's not necessarily a good thing. Long-term retention. also a hot topic for modern monitoring, for any modern monitoring platform, really, including Graphite. Um, Often we find operators running with 3 to 6 months of retention with Graphite. And doing so has the obvious limitation of preventing you from doing year over year type analysis. You don't have sort of that minimum 13 months to sort of do a comparison of now versus what occurred last year. Um, but that's kind of the exact reason that people go about setting up Graphite in that way. The idea here is that let's prevent the users from asking expensive queries that simply won't ever return. Whisper is just not good at responding to those types of queries. Now, the trick here, Whisper does actually offer the ability to perform roll-ups of your data, sort of different granularity depending on the time period that you're asking for. But those roll-ups are the type of configuration that occurs when you stand up Whisper for the first time. And once it's stood up, altering those roll-ups, it's a complicated and error-prone process. Operators are they're typically stuck with that configuration once the deployment is stood up. And that sort of like prevents any sort of query performance tuning or storage optimizations or anything like that. Like once the deployment stood up with whatever those preconceived notions were, as the organization grows, there's not really a way to go back and sort of challenge those and change them. Another challenge relates to a concept I call spurious aggregations. It's related to StatsD, but the idea here is that spurious aggregations, they tend to fall out of Graphite deployments that are shared by many teams within the enterprise. So for example, one team may choose to calculate the 95th percentile latency, another team wants to calculate the 90th percentile latency, and aggregations like these, they're typically generated by an upstream aggregator, StatsD. And so in theory, you would be able to go into StatsD and you would sort of enumerate and say, well, team A wants these particular metrics this way, and team B wants these particular metrics this way. And there's a clear way to do that with these types of aggregators. But in reality, it's sort of a lowest common denominator approach is taken. A set of aggregations are typically calculated for all the classes of data points and then just simply dumped into Whisper. And the net result of that is basically the pre-aggregation and storage of a large number of metrics no one ever asked for nor needed. In a worst case, these spurious aggregations represent a majority of the metrics that are currently in Whisper. And of course, if like 90% of your metrics are things that people don't look at, that's confusing users. Like, why are these here? And then the other bit is that because you're sort of cluttering Whisper storage with all of that, you're slowing down queries along the way as well. We're going to talk a little bit more about this concept later too. So given these challenges, there are two natural options through which to modernize your Graphite stack. And the first one here, shown on the left, is to replace the Whisper database with another database. Ideally something performant, modern, supports data replication, indexing through which to support data safety, performant querying, things like that. And the second option, shown here on the right, is a partial or complete overhaul of your existing Graphite ecosystem. Within this particular model, which is certainly a more significant step, you more or less get to keep what you like about Graphite, and you get rid of what you don't. So option one, so this is the drop-in replacement of Whisper with a compatible time series database. For option one, you are going to surgically replace the back-end database and effectively breathe new life into that existing deployment. By doing so, you basically are keeping everything else within the ecosystem exactly the same, except for that back-end time series store. We're no longer going to use that flat file structure that I was talking about, use something super modern, something performant. And now we're better able to scale ingestion and querying through both vertical and horizontal scaling. We are also better able to protect your data through a replicated data store, multiple write copies, and then also better able to efficiently manage the long-term storage of your telemetry. A potential implementation for option one, could be Circonus IronDB. IronDB, it's a distributed time series database. It supports drop-in replacement for Whisper. And with IronDB, you can vertically and horizontally scale the database up or down as the monitoring needs of the business changes. So if you're sort of top of mind right now, like how many metrics might IronDB be able to handle? It's designed to handle billions of metrics. And we actually have some production deployments that are handling upwards of 500 million series today. So when I say vertical and horizontal scaling, like, real world, we can handle hundreds of millions up to billions. In addition, you also get data safety guarantees with that. Increased performance comes with the sort of multiple write copies. You're able to sort of come and read from multiple places instead of just one place. And once IronDB is all stood up, you can migrate all of your existing data over from Whisper and make use of your same exact existing telemetry pipeline. Often you don't need to make any changes there, and you just continue to use Graphite Web or Grafana for visualization and alerting as you did previously. So a case study, a big company that's using this today. So Xander, it's an ad tech company that was recently acquired by Microsoft. They rely on Graphite for real-time time series data to support their programmatic ad buying platform. So historically, Xander had relied on sort of legacy conventional stock Graphite for all of their metrics. And their deployment had actually grown to, I think it was something like 104 nodes at a certain point for storing all of this telemetry. A lot of overhead in managing that much infrastructure. You're talking about racks and racks of systems. You've got systems that are going off lease, you're replacing them. You've got power supplies that are going bad, you're replacing them. Drives are failing, you're having to replace them. All that fun stuff. And then over time, it really became a very significant headache for the team, and they began to explore other options and ultimately settled on IronDB. After adopting IronDB, they were able to reduce that footprint of 104 machines down to just 26, almost fits in a single rack at this point. And the net result of this swap is less servers, less management overhead, and a substantially more robust solution as a whole. Best of all, Xander was able to add write replicas, providing true data redundancy to their monitoring stack. That was important for them. And then there's also the added benefit of allowing them to significantly increase their telemetry ingestion as well. When you have these sort of like multiple write copies, you also have multiple places to go read from. And so both of those actually scale up. Switching over to option two. So this is basically migrating your Graphite deployment over to a compatible SaaS platform. And the idea here is effectively that you are refactoring your Graphite. Within this model, you keep what you love about your current Graphite and you get rid of what you don't. Within this model, you can do a bunch of things. You can replace the legacy ingestion components with modern, performant, highly scalable components. So for example, things like StatsD or StatsD Relay, Brubeck, Carbon Relay, components like that. There's all new versions that you can be migrated over to. And the other trick here is that you can empower downstream users to start leveraging histograms through which to enable modern SRE practices like SLOs, error budgeting, things like that. And then also you can more efficiently manage the storage of metrics that you may not need. And on this latter topic, let's circle back to that earlier concept of spurious aggregations that I mentioned earlier. So many of you likely are relying on Graphite, and you're doing that in combination with telemetry provided through StatsD. Graphite and StatsD, they almost go hand in hand. Typically, StatsD data points are emitted by applications via UDP. They're received by an aggregator, something like StatsD or Brubeck. And then from there, you sort of like pre-aggregate all of the different aggregates that you want that you're going to use as part of your day to day. And when defining these aggregations, we often find that different teams, um, they want different aggregations. So for example, you might have one team as shown here, who's interested in the 90th, 92nd, and 95th percentile, and you may have another team interested in the 60th and 55th percentile. And we tend to see two different approaches in addressing this particular scenario, neither of which is particularly great. The first approach relies on pre-aggregation of what both teams are looking for to calculate all 5 of the percentiles for all of the stats-D telemetry that's coming in. The net result is pre-aggregation of a large number of metrics that neither team asked for nor needs. And worse yet, now they need to go manage the storage and sort of the implications of having collected that data for no particular reason other than that's just how it got configured. And now you have to live with it. And I would say even worse than that is that teams tend to also change the aggregations that they collect over time. And by changing, they're more or less just adding new ones to it. And this just further magnifies the issue. And you may think that what I'm describing here is sort of an exception, but based on my experience, this is more the norm. This is an extremely common problem within the space if you're using Graphite. And if you think this is the exception, like good on you that you've managed to avoid this particular problem, because a lot of people have made that mistake. And for the second approach, so sometimes organization, they're aware of the pitfall that I just described, and we're going to have team 1 and team 2. And they're actually going to come together and they're going to collaborate and they're going to come to an agreement on which specific aggregations they're both going to use. And that's going to solve this whole entire problem, right? Like we're not going to go ahead and generate like millions of metrics for no particular reason. We're only going to generate the things that we actually need. And on the surface, that might sound like a win, but ultimately, if you've got the two teams talking to each other and collaborating like this, it is likely that neither team is going to get what they want out of this particular conversation. There are often good reasons that teams will be leveraging or relying on different types of aggregations for measuring the performance of software and potentially their own performance. And now they've needed to compromise on what their gut was for that due to the underlying technology, which is not great. And of course, in this model, the teams are further disincentivized from changing anything as they are aware that modifying the aggregations will just further exacerbate this problem. And that's sort of the setup, I would say, for an even bigger problem, which is that most SLOs, they tend to be defined based upon the telemetry that the team already has access to, as opposed to what's best for the service. This is just how it often goes. And so we're now in a circumstance where our SLOs have sort of been shaped by what the underlying technology has constrained us with. And this is sort of the antithesis of what we're supposed to be doing as SREs, but sort of due to the limitations of the Graphite ecosystem and sort of the pipeline itself, we see this happen all the time. With histograms, this problem that I just described, entirely solved. Rather than needing to pre-aggregate each individual metric a team may want, we can instead pre-aggregate with histograms. And using histograms, you basically capture the full distribution of your submitted telemetry. And later, you perform an on-demand calculation to get the desired aggregation that you're looking for. So for example, like once you begin collecting histograms, you can start calculating more advanced things off of them, like arbitrary quantiles, percentiles, inverse quantiles, inverse percentiles. If you wanted to calculate like the 37.4th percentile, you could do that with histograms. If you wanted to calculate an arbitrary inverse percentile, you could do that too. And that's all without needing to manage or store any additional metrics or needing to reconfigure an aggregator or anything like that. You basically just collect histograms, just store the histograms, and then you will make on-demand aggregations through which to get the answers to those questions that you're looking for. Um, so to summarize, for this sort of SaaS monitoring and augmentation of your existing Graphite deployment, you're going to get more efficient ingestion out of that. You're going to get more flexible querying capabilities. You're going to eliminate spurious aggregations and cut down on overall metric ingestion. And once you've gone through all of that, you are now in a place where you can focus on modern SRE practices like SLOs and error budgeting. And a case study for this option. So Redfin is a real estate listing and brokerage service, and they rely on Graphite for monitoring of the various applications and services that power their web and mobile experiences. Historically, Redfin had relied on a legacy conventional Graphite deployment. Their applications emit StatsD telemetry via UDP, which was then shipped to a StatsD aggregator, and then from there, the resulting aggregations were stored in Whisper. And at a certain point, Redfin reached a place where they were actually emitting enough StatsD telemetry that it was becoming difficult to manage. And simultaneously, the team began considering and then adopting modern SRE practices. So they've got basically a system that more or less isn't keeping up, but then they have goals through which they want to modernize the way that they're thinking about their systems through SRE. And of course, those two don't go together. So eventually they began exploring options through which to either replace or augment their existing solution. One of the caveats for Redfin was that they had a very large number of existing dashboards and also a large number of existing alerting rules, which was one of their considerations here. They wanted to sort of figure out a way through which to hoist all of that up into a modern platform without having to rebuild it all. And they were able to do that. So after adopting the Serconis monitoring platform, Redfin effectively was able to re-architect their metric ingestion pipeline. They're using open histograms. You can read more about the histogram technology at openhistogram.io. But in adopting open histograms, they were able to significantly reduce the overall metric footprint that they were dealing with. They basically solved that particular aggregation bloat issue that I described earlier. And by doing that, they were basically able to aggregate on demand as opposed to sort of the legacy model of pre-aggregating all of that stuff. And by doing that on demand, it meant they no longer needed to keep all of those individual aggregations that weren't actually being used by the team. And now Redfin's team is able to simplify the creation and compliance monitoring of SLOs. They can benefit from the data safety of the broader Serconis monitoring platform. And also, they can discover new insights through the use of open histograms. Since you don't need to pre-aggregate, since there's no sort of effort required through which to come in and sort of like query the histograms that you've gone ahead and collect, it's not uncommon for people to sort of find some gems that are hidden in there, some needles in the haystack. Yep. And I think that actually wraps up the presentation portion of the webinar today. So we've got those sort of two different options that are offered by Serconis to help you either extend the life of your existing platform or to augment it. And from here, we'll switch over to some Q&A. I hope to hear from you there. If you happen to be watching a recording of this session later, please reach out to us at the above URL. That'll actually take you to our community Slack and you can ask questions there. And thank you for joining me today. Backend if you need it. Best of all, I would say Xander was able to